Hello dears, in this tutorial I want to simulate a hydraulic jump in HEC RAS. We have 5 profile and their discharge in meter cube per second. We have these discharges and we have this cross section. Let us open HEC RAS, File, New Project. Determine your directory, HEC RAS, HEC. Let be name hydraulic jump. Enter. Okay. From option, unit system, select it system international metric system. Okay. And if you want to make it default, tick this one also. Then create a rival reach, name it 1, let be 1. Okay. From cross section option, add a new cross section, station 0. Okay. Let be station 0, 60, station 10, let be 50, station 10, let be 55. Okay. 5, 40, let be 55, its elevation 50, let be 60. Distance 0, 0, 0, manning let be 0.018. You have to know the manning coefficient for your channel. Left bank here 0, right bank it's 50. By data, that's our cross section. Then option, copy current cross section, let be the next station be 100 meter. Okay. 100, 100, 100, and we add some elevation, adjust elevation, let be 0.2. Okay. Apply data, then option, copy current cross section, let be the station is 600. Okay. Distance from here it must be 500, 500, 500, and we have to adjust elevation at some elevation. Adjust elevation, let apply 5 meter. Okay. Apply data, right click, full plot. Good. Now from tools, within reach 600, 0, let be every 10 meter, interpolate, close. Good. File, save geometry data, geometry, jump. Okay. Then from flow, we have 5 profiles. Go to your Excel, copy, control copy, then select it, control V. Good. We have this discharge and reach boundary condition for upstream. Normal depth let be 0.01. Okay. Downstream, normal depth let be 0.01. Okay. File, save flow data, jump, flow. Okay. Then run, mix it, compute. Okay, let's see our cross section. That's for the first one. The first one is higher than the capacity of the channel. That's the third one. That's the third one. Okay, third one, until third one is good, but fourth and fifth one is not good for this channel. The capacity of channel is less than the flow. Okay, let's see the profile. Good. You see here is the profile. Okay. Let's also see the table. that is a Froude number. And here discharge, minimum channel elevation, water surface elevation, critical water surface, energy grade line, energy grade line elevation, energy grade line slope, and so on. That's all. I hope it can be helpful. Have a nice time.